Hi everybody, today we're going to learn about moles. Not the furry little creature, but moles used in science, specifically chemistry. So you probably have a question, well, what is a mole? Okay, well, it's very simple actually. A mole is a unit of measurement. You need to know that. And it's used to count things. That's its purpose. So it's a unit of measurement used to count things. Now, it's like a dozen. You're already familiar with this concept. A dozen is a unit of measurement, and a dozen is used to count things, usually eggs. So if I say, hey, how many eggs do you have? You might say, I have 2 dozen eggs. That's one way to count eggs, by the dozen. Or you could actually count each egg as an individual unit and say, I have 24 eggs. So think of a mole like a dozen. It's a unit that's just used to group numbers of things together. You might think, well, why would we use moles instead of a dozen? Well, you know that a dozen represents 12 things. And you can use a dozen to measure more than eggs. You can measure a dozen cars, 12 cars. Well, a mole equals 6.02 times 10 to the 23rd things. Okay, much bigger number. And in the same way, you can use it to measure many different things. Now, normally we use it to measure molecules or atoms or protons or electrons, very small things. Why do you think we would use moles to measure atoms versus dozens? I'll let you think of that for a minute. Okay, so let's talk more about this number right here. This number is called Avogadro's number, and it's important to remember that because you will hear this word a lot in chemistry. Avogadro's number. And Avogadro was a very interesting man. He enjoyed tacos. He loved guacamole made with real avogadros. No, but seriously, you have to know that Avogadro's number equals 6.02 times 10 to the 23rd, whatever it might be. So, can you convert that number into a conventional number? You might remember from our scientific notation unit, you just write this and then you move the decimal to the right 23 times. So let's do it. 1, here we go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. We'll put the decimal there. This is going to be a very, 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 very large number, as you can see. Yeah, good, good, good. Let's put in our commas. Now here's my question I have for you. How do you say this number? I'm going to let you look that up on your own time. Okay, and if you can figure it out, raise your hand and tell your teacher. And that'll be an interesting little factoid that you can remember about Avogadro's number. Let's put this number in perspective. I mean, this is a lot of things. Some interesting things that I've heard and read. A mole of donuts, if it covered the Earth, it would be a layer 5 miles thick. So if this is the Earth, imagine 5 miles. This would represent 5 miles thick of donuts covering the entire Earth. Could you imagine that? What about a mole of basketballs? A mole of basketballs would form a ball the size of the Earth. Okay. Another good one is, how much is a mole of red blood cells? So in the human body, I'll try to draw a person real quick on the fly here. Here we go. The number of red blood cells that represents 1 mole is more red blood cells than the number of blood cells in every person on the face of the earth. So if you added up all those red blood cells on everybody that's living on the face of the earth, it would be less than a mole of red blood cells. Here's one last one. How about, what if I gave you a mole of $1 bills, and you were a big spender and you spent $1 billion every second, per second? How long would it take you to spend all your money if you had a mole of dollar bills and you were spending $1 billion a second? The answer may surprise you. It's 19 million years, spending $1 billion a second. That's crazy. So that should put it in perspective. So a mole of a certain thing is many of those things. So the answer to the previous question I had was, well, why would we use a mole versus a dozen? Well, the reason why is to count very, very small things, that there's many, many, many of them. Can you think of what some of those things would be? I mentioned them earlier. Yeah, things like atoms and protons and electrons, very tiny things. As a matter of fact, how much water do you think is represented by 1 mole of water molecules? You think it's an ocean? Do you think it's a lake? Do you think it's a glass of water? 1 mole of water molecules? Well, it's actually about a big sip of water. So that goes to show you how small atoms and molecules are. If 1 sip of water, that would represent 1 mole of water. So that's just important to kind of grasp how big of a number a mole is and how small atoms and molecules and things like that are. So how do we use this? Well, first of all, let's do a little bit of practice here. Let's say, what if I had 3 moles of Chevy pickup trucks, and I had 2 moles of Honda Accords. Now, I'm going to give you a couple questions. Here's question number 1. How many moles of cars is there? Or not cars, let's say automobiles, right? Let's be careful. Automobiles. How many moles of automobiles are represented by 3 moles of Chevy pickup trucks and 2 moles of Honda Accords? That's the first question I'm going to pose to you. The second question I'm going to pose is, how many automobiles is represented by 3 moles of Chevy pickup trucks and 2 moles of Honda Accords? Okay, how many automobiles? See if you can think through this. All right, let's take the first one. How many moles of automobiles? Well, if there's 3 moles of Chevy pickups plus 2 moles of Honda Accords, and we know Chevy pickups are considered automobiles, Honda Accords are considered automobiles, so that would be 3 plus 2, and the answer to that is 5 moles. 5 moles. Okay. Well, what about this question? How many automobiles is represented by 3 moles of Chevy pickup trucks and 2 moles of Honda Accords. Well, on this one, how can we figure that out? Well, if you realize that 1 mole is 6.02 times 10 to the 23rd automobiles, then all you have to do is 5 times 6.02 times 10 to the 23rd. Make sure you punch these numbers correctly in your calculator. So let's see here. 5 times, now be careful, this is how you want to type in Avogadro's number, 6.02, and to put in the time 10 times 10 to the, you do second function double E, which brings up this letter E, which represents times 10 to the something power, and we're going to put in 23. Okay, that's how you have to input Avogadro's number to make sure your order of operations is correct and you're getting the correct answer here. So we hit enter and we get 3.01 times 10 to the 24. So here we go. 3.01 times 10 to the 24 automobiles. Now, you might think, okay, well, this is really easy, and good. It should be pretty easy, but here's where people get confused. They get confused if I'm talking about moles of automobiles versus just automobiles. Let me give you one more example, and we'll use real elements now. So let's say I have, how about I have 6 moles of carbon. Well, 6 moles of carbon would be 6 moles of carbon atoms. And I've got 2 moles of nitrogen atoms. So I'll ask the same question similar to what I asked before. I think it'll be easier for you. How many moles of atoms are there? Second question is, how many atoms are represented by what's in the box? Okay, you probably have the answer to the first one. So we have 6 moles of carbon atoms, 2 moles of nitrogen atoms. Therefore, we have 6 plus 2, which equals 8 moles of atoms, which is true. Now, how many atoms do we have? Notice that I have to really be careful that I'm making a distinction whether I'm counting moles or I'm counting atoms. Okay, that's very important. You don't want to get confused in what you're counting. So now I'm counting atoms. So now here is where I'll say, well, to know the number of atoms represented by these 8 moles up here, I go 8 times Avogadro's number, which is, right, 6.02 times 10 to the 23rd power. Let's punch it in. 8 times 6.02 second function double E 22.3. Enter. I get 4.816 times 10 to the 24. 4.816 times 10 to the 24 atoms. I'm not using significant figures right now. I don't want to really kind of get in the way of what I'm trying to show you here. But anyway, do me a favor. Do your teachers a favor. Please don't write the answer with this E here, the giant E, 24 atoms. Okay? You don't want to write your answer with this E. This is wrong here. You've got to understand that the E in the calculator means times 10 to the something power. There's a couple other things that I want to tell you as we wrap this up. Mole can be abbreviated to MOL. So a lot of times you'll just see MOL. So it's kind of a funny abbreviation. You're only writing one letter, but it is what it is. So this and this is the same thing. But it's not a molecule. Please don't think that a mole is a molecule. That's another common mistake. It is not a molecule. No. A mole is a mole and a molecule is a molecule. And I hope you have a tremendous day. Thanks again.